Okay, some more of the Chapter 3 practice test, and we just have several functions we have to take the derivatives up of and use the chain rule. So this is the cotangent square. Well, first of all, this is our convenient notation, but I don't really like this notation, so I'll rewrite this as the cotangent of 5x cubed, and the whole thing is squared. Okay, so I'm going to have kind of I think a triple chain rule here. So be careful on this one. So y prime equals, now this is going to be like x to the n. So this is going to be 2 times the inside, we're going to leave the inside alone, cotangent of 5x cubed to the first power. So this is like x squared would be 2x times the derivative of the inside. So I'll write it out like we did. So times the derivative of the cotangent of 5x cubed. Okay, so I can rewrite this. This is y prime. So everything to the left we leave the same, but to the right we have to kind of do some more work. So we got 2 cotangent of 5x cubed. Okay, and then times the derivative of the cotangent. Now, what's the derivative of the cotangent? Well, I got my trusty card here. The derivative of the cotangent is the negative of the cosecant squared. So that's going to be times negative cosecant squared of 5x to the third. But then I have to take the derivative of the inside, so that's going to be times the derivative with respect to x of the inside there. 5x to the third. This is y prime, excuse me. That's going to be 2 cotangent of 5x to the third. I can take this negative sign and put it out front here, negative. And then cosecant squared of 5x to the third. And what's the derivative of this? That's going to be 15x squared. So I think we finally got it now. So we can bring the 15 in front, so y prime equals, and negative 2 times 15 is negative 30. And we have an x squared. And then we can put the cotangent in front, so we've got the cotangent 5x to the third times the cosecant squared of 5x to the third. Okay, so there's your final answer. Sorry. So there's a little bit of work to that. And again, you've got your chain rule working a couple of times inside there. And this is a good way to do it so you don't foul up. And you probably want to do this on another sheet of paper and then transfer your answer over, but make sure you staple that to your test so we can see your work, all your wonderful work. Okay, let's take a look at that was the number 11, number 12. And number 12, as I look at this, I see, I want to take the derivative in y equals x to the 3x. Now we can't use the power rule because this has got to be a real number. All right? All right? It can't be a variable. So it looks like I'm going to have to take the log of both sides. So I say the natural log of y equals the natural log of x to the 3x. And then I can move that x to the 3x in front, so the natural log of y equals 3x, natural log of x. And then I can use implicit differentiation and solve it like that. So this is logarithmic differentiation. Good example of logarithmic differentiation. So I take the derivative of both sides, so this is going to be 1 over y dy dx. And that equals, it looks like I've got both variables here, so it looks like I'm going to have to use the product rule first, which is 3x times the derivative of the second, which is 1 over x, plus the second, which is the natural log of x times the derivative of the first, which is 3. So this is 1 over y dy dx. dy dx. Okay. Sorry about that. And that equals, and these x's cancel, so I just have 3 plus 3 times the natural log of x. And then I could factor that out just to make it 3 times 1 plus the natural log of x. It's a little easier. And then we just have to multiply both sides. We just have to multiply both sides by y. So we end up with dy dx equals, and if I multiply, I can put my y up here, y times 3 or 3y times 1 plus the natural log of x. But I want it in terms of x, so what is y? So I have to go all the way back up, and remember y equals x to the 3x. So it's going to be 3 times y, which is x to the 3x, times 1 plus the natural log of x. So that would be your final answer. Okay? 3 times x to the 3x times 1 plus the natural log of x. So that's a nice example of logarithmic differentiation, something that you should know how to do, and not too difficult, I don't think. Okay? So I hope that helps.